Hi everyone, and welcome to today's session. So today we'll be talking about the ARC challenge, and I've been spending a few months trying to solve it. It's really quite interesting. It was created by Francois Cholet. It's a series of puzzles that you need to. Okay, maybe I go to the next slide. Like a series of puzzles where you need to go from input to output. There's 10 different colors of each cell you can have, and the grid can be ranging from various sizes. I think the smallest is 1 by 1 and the largest is 30 by 30. Okay, so the idea is if you look at these input-output examples, you will see that there's a certain pattern. Okay, the pattern is not made known to the human or the computer that is trying to solve this. The pattern must be inferred. So this is a test of few-shot learning, where given a few examples, you need to learn a certain pattern, and then you need to replicate it for the test input, which is not seen. So over here, can anyone tell me the pattern for this? What's this input to output?
Is to fill in things that are fully surrounded, I guess. It's like to fill in gaps.
Correct.
Yeah.
So fill in things that are fully surrounded by yellow. Okay, so this is a fairly simple problem for humans. Okay, but for computers, you need to use algorithms such as flood fill that are not very natural. So it seems that to solve these problems well, humans can do it because a lot of these problems build on our human priors. Like we see objects overlapping, we already know that there's object permanence at the bottom. So there are some problems testing those kind. Gravity, pixels dropping down, very natural to humans, not very natural for computers. So the ARC challenge is challenging for computers because a lot of these priors are absent. Okay? Computers just don't see the world the way humans see it, right? And so there's a few things that I tried to use to solve the ARC challenge. Mainly, I'm trying to use a GPT-based approach because I feel that GPT-based approach is very flexible. So you will see why. So I tried stuff like broad to specific prompting. Okay, you first start to ask GPT, what's the broad plan? Then after that, from the broad plan, you condition on it and you ask what's the specific plan. Works pretty well. Human priors, I tried to use text to prompt. After a while, I use functions to prompt it. You will see why again later in the slides. Image interpretation. Right now, to try to solve the ARC challenge, we kind of want to give GPT the input, like in terms of pixels. Okay, but sometimes when you want to solve this problem, you cannot just use pixels because sometimes you need to move an entire object from left to right, and it's very hard to do so with pixels. So this image interpretation is quite important. And I did a new view inside I use an object view, inspired by some of the papers that also use object view for GPT. It works pretty well. Okay, I'm sure with other views, you can solve other kinds of problems as well. And then lastly, there's this environmental feedback loop, which is basically saying that you don't just give GPT one try to solve it. You let it try, let it see its answer compared to the model answer for the training set. And then we try to see whether or not GPT can learn from its mistakes and solve it. Same thing for compile errors as well for codes. So this actually works quite well. Some problems cannot be solved by one single iteration. You can solve by multiple iterations. And actually, there's one last part on memory, which I haven't implemented yet, but I'm very sure it will help quite a bit for the ARC challenge. So let's begin. Right, so these traditional methods that have been used for AI problems. The first one is the good old-fashioned AI or GoFi. I lump program synthesis in that side also because program synthesis traditionally involves a lot of hand-tuned, handcrafted functions, and you need to do some breadth search or do some heuristic to choose the kind of programs that are needed to solve it. Or you could be like Douglas and use some form of inference, like symbolic inference. This actually also needs quite a bit of hand-tuned instructions because you need to define what functions as well. But this have worked quite well for certain problems that are very close domain, right? But the problem with ARC is that this one, if you want to do this kind of method, you will have to define a lot of functions. So this is one problem. If we use the other approach, we just GoFi, and we just go straight to deep learning. All right, deep learning, as you all might know, it actually requires quite a lot of samples to learn. For example, to train an image classifier on ImageNet, you might need 10,000, I think 100 over 1,000 samples, millions of samples. Okay, so if you look at a smaller problem like digit recognition, like MNIST, you need about 50,000 samples for the training. Okay, and then you just run through 10 or 20 epochs, which is 500,000 iterations. So you look at the arc challenge here, they only give you 3 input-output examples. Okay, that's not going to happen. Okay, deep learning is not going to solve it well, right? Because there's just too few samples, right? So what is the kind of approach that might solve it? Yeah, I believe you must combine like the merits of both approaches. And that's why I've come to think that maybe transformers could solve it. So transformers is what fuels like the latest language models such as like ChatGPT, GPT-4, Claude, I don't know, Bart, those kind of language models use transformers, and it's quite cool because what these transformers do is they take in a certain input and then they just try to predict the next token. So like, for example, if the tokens are like the cat set on then next token, right? So you're supposed to predict that the next token is like mat. So like you can predict mat is like 0.8 or 80%, it will be mat, and like floor is like maybe 20%. So somehow through this use of prediction of the next token or what will come next in the sequence, the transformer architecture is able to learn some form of representational space that you can find out like, oh, what does cat mean? What does set mean? Based on the relation to the other inputs. So you can form quite complex representations. Like you can even know like A is the son of B, so B is the father of A. Yeah, you can learn all this just simply through next token prediction. Quite remarkable. And at its core, it uses some form of attention to use, like, for example, all these tokens, like will take in like certain values from the earlier tokens and get refined to like a new kind of, like maybe this is a certain vector. Okay, it's harder to demonstrate here, but in terms of like vector space, like you have a certain token here. Okay, let's just use the cat. So initially cat was like that. After it's like interacted with the other tokens, it might be shifted to another point on your vector space. Okay, and this way of doing this multiple self-attention modules here, this part here has helped to create better representations. Okay, so this part here enables you to do something that we have never really done before in the last few years, all right, which is basically to do very, very flexible computing with just one single trained language model. So with this transformer architecture, you don't have to train the weights anymore. All you need to do is to do some form of engineering of the prompts at the output, at the input here. You need to engineer the prompts, and you can actually change the behavior of what the language model does. So it's pretty amazing. So I'm just going to go through very briefly because I talked about this before in some of my other sessions on like prompt engineering. So this is the reason why GPT might be able to solve the arc challenge. It is very flexible. It might be able to configure to solve like an entirely new domain like the arc challenge. Okay, so zero shot is you describe the categories, okay, and then without any examples, GPT can actually solve the problem for you. So in the classification case, it looks like this. So you can ask GPT to like do some location like mountain, classroom, garden, and then you can classify like this one. Oh, this is a mountain. Okay, this one eraser. This is in the classroom, and this one is in the garden. So I tried this before. It got perfect score, just without even any examples. So if you can describe your categories quite clearly in an unambiguous way in English language, GPT is able to do zero-shot learning. Okay, and that's very useful for arc, because then you can just describe maybe certain human priors in language, and hopefully you will learn. Okay, so let's keep that in mind first. Next, if zero-shot prompting fails to work, you can also use few-shot prompting. So you can give it some examples, input what, output what. Okay, then you can ask it, okay, this is 6. You can even say you are a number classifier, okay, to classify even or odd. And you can do it like that, and then you give it some examples, assuming that it doesn't know what's odd or even. Okay, this is actually only required if the English language description is not sufficient to give it all the like possible use cases. So you might want to ground it with some input and output examples. So I will use the word grounding a lot because this entire thing for the prompt, okay, will ground the generation of the later tokens. Because as you know, GPT, when it generates tokens will be grounded based on earlier tokens. So this strategy will be used a lot of times. Like when we do broad and specific prompting, you first generate the broad intent. Then because you generated the broad intent, let me just write here, because you generated the broad intent here. So when you actually ask GPT to do the specific intent, this will be actually grounded on broad intent already, because when you ask GPT to generate the next few tokens, it will refer to the past X tokens. Okay, like for ChatGPT is past 8,000 tokens, GPT-4 is past 32,000 tokens. Okay, there are more tokens nowadays. I think Claude is 64,000 tokens. So people are increasing the context length where you can ground the previous, you can ground the generation of your tokens based on a larger and larger context length, which is great for the ARC challenge. Because right now, my solution, I'm only using the 8,000 context length. There's a lot of limitations. I can foresee that with the context length being increased, you might be able to solve more and more of the ARC challenge, okay, especially the larger grids. Okay, any questions so far for the zero shot, few shot? Okay, so this is one very interesting example. I'm just going to show you, like you can do very, very flexible prompt conditioning just by giving some form of context, or I would call it grounding. So for example, you can say that, oh, you are a salesperson. Okay, not just describe what you are, what role they are. You can also give like some examples of, okay, these are the products. Okay, you sell apple, banana, and carrot. All right. And then if let's say the customer says your apple product is too expensive, okay, I tried this prompt before, GPT is able to say that, oh, why not you consider the banana and the carrot instead? So if you give it enough examples at the beginning, or give enough like categories or scope of where you want GPT to generate, or what you want GPT to generate, the answer would be very plausible. So this is something that is very useful for the ARC challenge, because for those who have done the ARC challenge, like Douglas, you will know that the ARC challenge, the hidden test set is going to be different from your training and your evaluation set, because in the ARC challenge, they don't want to repeat the kind of tasks. They want to do like test how well you generalize to a task that is not even in the training set. Okay, so this is very difficult. It's a very difficult problem, because in traditional deep learning, the training and the test distribution is about the same. Now the test distribution will be quite different from the training distribution. And we want GPT to, given a new context, given a new like problem, figure on its own what it needs to do. So this way of this property of language model generation is actually quite useful to solve up. And I think this will be very useful in AGI systems as well, because you can really just like learn on the go. Okay, with just some grounding as to what kind of stuff you want to generate, you can learn very flexibly in any kind of input, even those you have never seen before. All right. So this is basically the key crux of the solution that I'm trying to describe. Okay, the solution is heavily inspired by Language Up. So Language Up is a paper, all right, that says that in the original ARC task, okay, you can actually do it in a two-player game. So you just look at this green player here. This green player sees the input-output pairs, and his aim is to describe the input-output pairs in an unambiguous language manner, such that a person who does not see the input-output pairs can get the right answer. So over here, look at the input-output pairs. You have this blue square going to another like grid here. Okay, can y'all tell me like what's the relation here? Like if you look here, it is
basically you bring the closest. There are like 4 different color squares on the 4 corners of the center square, and then you just bring them into the corners.
Yeah, correct. So this is quite obvious for humans, right? But this actually, if you were to do some form of mapping, there's a lot of rules that you can use to map. It's a bit tough, okay? But one thing is that if you can describe it by saying that move such that it covers the closest corner. So this person who's the builder, who just looks at this instruction like that, will be able to generate the outcome, okay, of the test set. So there are 2 people in this game. So this person from input-output to text. Okay, and then this person will be from text, and given a test input, we need to convert it to the test output. So the solution relies on having this kind of thing, because if we can generate the text that is needed to describe the arc, all right, you can actually use GPT to like use the language to solve the arc directly. Okay, at least that was my initial thoughts. So I'm going to let like briefly touch on some initial ideas I had about 2 months ago. Okay, and these ideas are also in like my archive paper. You can take a look. So the paper is called An Approach to Solving the Abstraction and Reasoning Corpus Challenge. Unfortunately, it didn't win the Lab 42 essay competition. Okay, but I think this is quite an interesting way that we can solve the arc challenge. So you feel free to check it out. So the idea is following the language arc. Okay, by the way, this language arc paper, they did not use the GPT to do the description. The description is done by a human. Okay, and the builder here is also a human. So they just want to see like if we were to express arc in language, how much of arc can be encapsulated in language. And it turns out that actually 88% of the task can be done this way. All right. So the first idea is we ask GPT to do both sides, the describer and the builder. So the describer will get the language description from the input output, and the builder will then use this language description, okay, and code a Python program to solve it. That's my first idea. All right, then I realized something, all right? There's a lot of problems with this, code doesn't run very well. Okay, so there's a problem with GPT, all right? The problem with GPT is that if you use GPT to get you some code that is not very common on the web, it just doesn't do it that well. I mean, I tried to do it on some reinforcement learning code as well, some very specialized code, like multi-agent PPO, that kind of stuff. Like you don't really see it very often, and it somehow doesn't really do it well. I mean, if you ask GPT to like go through some very specific package, I don't know, maybe now the package will be like LangChain. Okay, I don't know whether LangChain is in GPT, but if you ask GPT to generate stuff like LangChain in a very specific use case, okay, you may not get good generation. Okay, this is the same for arc, okay, because this Python program for arc may not have been seen before, okay, or maybe quite different. So there was a slight issue with this. So I changed tack for the original paper. Okay, instead of using the program, I just applied on JSON input directly to get a JSON output. And actually this worked quite well for some tasks like pixel-based tasks, because you can just copy paste the pixels using attention, right? And I also did some form of prompt engineering, asking it to do a broad then specific generation. Okay, then I thought, okay, let's do this idea even more. Okay, let's imbue some human bias using text. Give some examples of the standard actions that the model can take. Okay, and this worked even better. So this is my 2 months ago idea. Okay, this is not the idea that that I have right now, but I'm just going to show you like my thought process. So this is how the prompt was generated. This was given in the GPT-4. So we first described like the row of GPT. Like this is the row. Okay, so the row is you are given a series of input-output pairs. Okay, they are not representative of any ordinal ranking. Very important. Okay, if you use numbers like 0 to 9, GPT might say, oh, the value of the pixel is 5. The value of the other pixel is 4. So the output should be 5 plus 4 equals to 9. Okay, unfortunately, humans don't think like that because we don't associate a color with a number, and then we don't. Imagine doing color addition. Yeah, you don't really do that unless you are mixing colors. But in this case, you don't want GPT to do vector, or you don't want GPT to do number addition, number subtraction, or modulo. So you need to say like not representative of any ranking, right? So this is quite important. If not, GPT would do like some form of solution space that you don't want it to do. Okay, because that's not part of human bias. All right. So you have to infer the simplest possible relation. Okay, this is very important also because there are some GPT tasks like this. If you have a color blue, you go to orange. Okay. If you have a color blue, you go to blue. You have color orange, you go to orange. I mean, the example could be like you have a blue square and then you go to blue cross. You have an orange square, you go to orange cross. Okay. So the input-output examples might just be 2 or 3 of them, like a blue square, blue cross, orange square, orange cross. Then the test would be something like this. Yellow square goes to, yeah. So for humans, you look at the shape. For computers, they will have problems, okay? Because if you don't ask it to generalize beyond the color, all right? When it comes with yellow square, it will just give a random answer because it doesn't know the relation. So this simplest possible relation is trying to say that, okay, we want it to get a more generic kind of answer, right? So this is quite important. This prompt here was quite important. So we then describe like what can the input and output be. So this is the first time I like do different views, like entire grid being the sandbox. So like you manipulate the whole grid, or use part of the grid to depict object instructions of how to do the task. Like sometimes at the side of the grid they have like red, orange, yellow, green. Then you use that to map with the bigger objects here. Okay. Then yeah, you also might have some stuff like symmetry. So all this I just try to use words to prompt it. All right. And the output can be same size. Output size can output one of the predetermined patterns, right? Can also use to show the ordering. So this was my initial idea. Just use the output to prompt it. It didn't work too well. Okay, it didn't work too well because like sometimes GPT didn't know like what exactly this means. Okay, because it doesn't have examples.
Could you share a bit about where the problem happened? Was it happening in the first part where you're trying to describe the input and then create the text description of the task, or did the problems occur in the second part where it's generating the output?
Okay, based on my prompting experiences, GPT is actually able to get the language description like more than half of the time, like 70–80%, you will get it right. All right. The problem lies in using it to encode a program or encode the text to like infer it. So it's more of the second part that's the problem with GPT. So I'm very, very impressed with GPT's ability to get the language description.
Understood.
Yeah, but I mean, not for all tasks. I mean, for some tasks that like ask you to like do some form of object comparison or this, if you don't prompt it specifically what to do, okay, you don't ground it in that kind of problem space, GPT is not able to give you the right language generation for that space. So a lot of it depends on how you ground GPT, and all this actually is to ground GPT into that kind of problem space. Yeah, if Arc Challenge was just about manipulating objects, I think my code, this kind of code can solve like 80–90% of the tasks already. It's just doing objects. Okay, but if you need to do other kind of tasks like overlaying grids, doing a small input space to ground a larger space, all this requires like different kinds of prompting because you want to ground it separately in different instances. And yeah, this is what I realized. You kind of need to hand engineer your prompt a bit for GPT to know the problem space. So I'm not too satisfied with this approach because it means that there's still a human needed to step in to make sure that things are done correctly for the prompting. I mean, if you let me think about it some more, maybe we could automate this process. So I haven't thought of how to do it yet, but I'm just going to try to solve as much as I can with a human in the loop first. Then we can think about how to take the human out of the loop if possible. All right. I hope that answered the question, Leonard.
Yes, thank you.
Yeah. So this is like how I ground GPT in the actions. Okay, so that's now was grounding in like what kind of input-output problems there are. This is the action. So we can say that, oh, actions is object view, defined as continuous squares connected horizontally, vertically, or diagonally. Okay, and I specify these 0 values are the separation. All right, so this actually GPT-4 can do it quite well to identify what objects there are, like 90% of the time, but 10% of the time it makes an error. Okay, so it's quite good, but not good enough. So you know, if 10% of an error, you still get the test case wrong. Okay, because if you generate the answer 1 square or 2 squares off, it's still wrong. So unfortunately, because of the precision needed for Arc, just using text-based descriptions like this wasn't sufficient. All right. This rotation reflection symmetry is not too bad also for GPT. But again, just using attention-based mechanisms for the initial grid to the output grid in terms of JSON, it wasn't enough to get the accuracy needed to solve Arc. Okay, same thing for segment view. It's not bad. You could identify the segments, but then again, this part here, this logical inference part, where you know you need to do stuff like XOR, or, and I mean, if you want to ask it to do like 1 XOR 1, right? I mean, it can get you 0. I mean, if you try this in GPT, it can do it. But if you ask it to XOR a grid of numbers like that, yeah, you ask it to do something like that, it doesn't have this, okay? Because in order to do this XOR, you need to first do it in terms of binary. You need to convert this to binary. So you need to prompt it one more time, convert to binary. I tried to prompt it to convert to binary. It kind of worked after I do that. And then you can convert this to another binary one. Yeah, so a lot of it is understanding what is natural in terms of the data set on the web. So if you do this, you ask it to XOR, you can do it. Okay, but it's a very lengthy prompting process, and I can tell you something. Okay, GPT is not good at logic. I mean, I'm sure you already have realized that logical operations are best done with computer program functions. Right? If you want to use GPT for logic, it's as best as what it can like see online. All right. If it's not there, it's probably not going to happen. All right. So stuff like maybe Prolog might be better at logic. GPT is not that great at it, but GPT is great at matching inputs to outputs. Okay. So that's what we are going to use GPT for. Okay, match inputs to outputs. All right. So here we can see that this is how I condition. What's the broad description? What's the specific description or step by step? And then apply this to test output. Okay, so this was the very naive view that I did about 2 months ago. So let's take a look at like how this is. So like, for example, like a task like this for the evaluation task. Okay, it managed to say that, oh, the broad description is extracting non-zeros from specific positions in the input. All right, so these are the positions. And then after that, place this. So this is the broad, and then this is the specific intent. The specific is here. And then you can see that it manages to get the right test outputs by using these operations, and you got the test output, which is quite cool because, you know, I didn't even like know like this task in advance, but GPT just looking at the JSON grid itself is able to get the broad and then specific relation. Right? You all might be asking me, you know, why is there a need to do broad then specific? Okay, because for very complex tasks, if you ask it to do a very specific operation straight away, the chance of failure is very high. Okay, so like how humans think, normally when I ask you to like walk from point A to point B, you don't think in terms of I move my left foot, then my right foot, then the left foot, then the right foot. You don't think like that. You think, okay, in order to go from point A to point B, first I need to maybe take a bus. I need to go to the bus interchange. All right, so you plan point A to bus interchange. Then you need to think, okay, what bus should I take? Then after that, when you reach to like the bus interchange for the other side, how do I get from the other side bus interchange to point C? So you break down your problem into sub-problems, and then your sub-problems, you then say, okay, what bus do I take? Oh, okay, what's the route from point A to the bus interchange? So this is similarly done. First, you ask for the broad intent, which then you can say, okay, from point A to bus interchange, then point B. Okay, then after you ask specific, okay, how do you get from point A to bus interchange? So this is exactly what the intent is for GPT. Works very well. This works very well, by the way. Yeah. So the language description most of the time is correct. Okay, the problem.
Are you asking GPT to be the builder here? I mean, actually, on your broad description of the input-output relation, were you the describer and then GPT was the builder here, or was it both, the describer and the builder? In just this, in these examples,
it's both. It's both. So the builder part is here. So this whole part here is the builder.
Okay.
So GPT will build itself, and then GPT will also the builder is at the bottom. The top part is the describer. Sorry, yeah, this is the describer. So the describer describes it in terms of step-by-step actions.
In a way, is this sort of chain of thought? I mean, I know it's different chain of thought programming, prompting, but you are forcing GPT to go through these 2.5 steps. And that's brilliant, because if it doesn't do it, it'll never do it, right? And that's what you're. Right. Yeah. Okay.
It is chain of thought. It is chain of thought using prompting, using sequence of prompting. So I prompt it in sequence, the broad and the specific, like that, broad and specific. So this works quite well.
Just wondering, did you ever try asking it to double check if its language description is correct?
Yes, I tried.
So like you have the language description, then you asked it to evaluate its own description on the first 3 test samples, right, and then ask it to refine it.
Yeah, that was actually my intended extension to this approach. I wanted to have GPT fact checkers to use the language and use the input-output, and then see whether it matches the input-output pairs. Okay, but let me tell you the problem, all right? The problem is GPT doesn't execute the language instructions that well. So it didn't perform that well as a fact checker.
Interesting, okay.
Yeah, but it did the description pretty well. But it didn't do very well as a fact checker because like sometimes it misses out like 1 or 2 pixel position and they say it is correct. I mean, we cannot allow that to happen for up because up every pixel is important.
How do you pass the instructions to the fact checker? Do you only pass the language instruction, or do you also ground it in the inputs with the JSON?
You can just pass this whole thing. Pass the step-by-step instruction. And then you ask it to say, evaluate this input-output pair and see whether it matches this description.
Maybe it's also good to include the initial JSON, because maybe it doesn't understand the language instructions.
Oh no, but if you ask it to fact check, you will give it input JSON.
Right.
JSON, and then like the step-by-step instructions.
Right. Got it.
You already have the JSON already, so it just needs to see whether it matches.
Understood. Okay.
Yeah. So unfortunately, GPT is not that great at doing a fact checker. So I had to use a different approach. So this is the limitation. These are the limitations. First is context length. So JSON representations of very large grids, 8,000 tokens very easily exceeded, right? I mean, the grid like 10 by 10. Okay, imagine you need to do your grid like that. You see, your grid is like that. 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Okay, I don't know how many I typed, but you get the idea. So 1, 2, 3, 4, 5, 6, 7. Okay, so let's say the grid is like that. Okay, how many tokens do you think this is? Right.
There are 20 elements, and then there's like each one is represented by two tokens, right? So
yeah, so
maybe like 40.
Naively, you think that is 20 or what, but actually, if you think about this way, like this bracket is 1 token already. This one is another token. Then like each digit here is like 1 token. The comma is another token. Okay, and in some cases, the space bar is a token also. Because if the comma and the space bar don't occur together, then this cannot be grouped as by the byte encoding cannot be grouped together. I didn't really check using the tick token to see how many tokens this is. But if we just go by the worst case, okay, the worst case is every character is a token. So this will mean that assuming each number has like a comma and a space, this one is maybe about 30 tokens per line for every 10 width. So it's like about 60 tokens. Okay, so imagine a 10 by 10 grid. Yeah, I mean, if we can check this out more accurately with tick token. Okay, I mean, we can check it out. But this one will be 300 tokens already, 10 by 10 grid. And then imagine you have input-output pairs, right? Imagine you have 3 input-output pairs. Okay, that's how many tokens? That's about 900 tokens. All right, then you have the output pair, then you have the test input. So this actually 10 by 10 is already like, with all the description of the grounding of this, that will be about 5,000 tokens. So it's very easily to bust the 8,000 token. Of course, if with 32,000, I can do a lot more. I haven't really tried the 32,000 yet because it's quite expensive. If you use the GPT-4 API with 32,000 tokens, if I max out the tokens, the cost for inference is about 70 cents to $1 in order to generate the full set of tokens for each prompt. So that means that every up task will cost minimally like 70 cents. so it's pretty expensive. So I'm trying to get this whole thing done properly first with the 8,000 tokens. Then I'll try with the 32,000. Yeah, but you can see that this is a problem because GPT, the way that we characterize tokens, okay, and the limited number of tokens we have to ground the generation will cause problems in terms of the context length, right? Multiple input-output samples, the instructions for grounding, all this will. This is actually a huge issue for GPT, but it's not that big an issue if we limit it to 10 by 10 grids. So if you limit to 10 by 10 grids, it's still okay, right? So of course, it depends on how big of an up challenge you want to solve. Okay, if you want to solve 10 by 10 grids, I think this method is very promising. If you want to solve more, you have to wait for like advancements on context length, right? So that we can put in more context for GPT. But it's quite interesting because GPT is not exactly trained on up, and it can describe up pretty well. So I'm actually quite optimistic with GPT solving more than half of the up challenge. Okay, with better prompting, of course. Right. So just as a benchmark, the current best method, I think, is 33% of the up challenge, the solve rate. If you combine all the best methods together, you solve about 33%. Okay, I'm quite sure GPT can solve more than half. Okay, if we do it well. All right, so over here, there's also one problem that I saw, is that if we just ask the text to ground what an object is, it may not get it accurately most of the time. Sorry, it may not get it accurately all of the time. Most of the time is okay by just describing objects are continuously connected. Okay, so this means that we may need an object view. Okay, we need to give it the view explicitly to tell it, okay, what is an object? What is grouped together as an object? And the last part is what Leonard said, the fact-checking abilities based on just text alone is limited. Okay, because GPT may not be able to apply the operations well to like a string. I mean, you can try this, like if you ask it to like do a certain string and then you ask it to reverse string and then ask it to add something to the back of the string, ask it to reverse the string again, you know, unless you prompt it to do step-by-step prompting, okay, which I tried to do also. I tried to ask it to do step-by-step and then display the output after each step. Okay, it can work for simple problems, but once you do very complicated maneuvers like, you know, rotation or this, it doesn't do it that great. Okay, maybe it's also because I didn't ground it in some examples of rotation. So it's all reliant on just text. So if we give it more examples of like how to do the actions, maybe it can do the fact checking better. Okay, so this is something that I found out. If you ground it in some form of function input output, it tends to do the instructions better. And it tends to generate better instructions also. So this is the basis for what you're going to hear next. All right.
Could you briefly say what an object is? Not sure what the
yeah,
is.
sure. So like over here, if we talk about objects, there will be continuous elements of colors like that.
So like a rectangle, like a square, like diagonal. I got it.
Yeah. And also in some problems, the object is made up of multiple colors like that.
I see.
So there's a lot of different, and some cases the objects, diagonals are considered the same object. Some cases diagonals are not. So there's many different interpretations of objects.
Understood. So what you meant in that line was to give it a description of like what might appear as objects.
Yeah.
Got it.
So I'm going to talk about what improvements I've done, okay, because this will be the focus of today. What you have seen earlier is just some thought process of what I tried to do initially and how it has failed. And then these are the improvements. All right. So first, context length, right? I tried to bypass the context length a bit, so I can do like a bit larger grids now, like 13 to 14 width and height. Okay, by just converting it to like a list of strings format. So this is actually not the best approach. Okay, because if you know how tokenizers work, you know, sometimes they may not tokenize this
as separate.
Yeah, correct. It might be chunked together, correct. But I realized that for most cases, you know, this still works pretty well. But of course, if you separate it, the pixels, it actually might work better. Yeah, but if you separate the pixels, you're also going to increase your context length by a lot. Yeah, so
did you consider using something other than dot? Because dot is quite a common occurrence. So maybe it's tokenized as one token. Maybe you can do something like tilde or something, some other unused.
Yeah, possible. Yeah, maybe I can use add or use And thanks for the suggestion. Yeah, I can go and try it out. Okay, so this is what's happening. So like instead of like using numbers, okay, I can just use letters and ground the like object representation like that. Y'all can see that this actually matches with this one here, right? Yeah, so like this is the red color and this one is the blue color. Okay, so this is like how I tried to make the context length a bit less. I don't think this is an ideal solution because I think separating the pixels might be the better solution, because I realized for some problems after I did this, it just doesn't distinguish the pixels quite well anymore. All right. So this is a bypass for some methods. For large grids, but it actually hinders the performance. Yeah. So I'm still thinking about like how do I should I go back to like a list of numbers, like the JSON representation? So I'm still thinking about that. Yeah, maybe that's the next step I need to do, because this actually hinders the problem solving capabilities. Okay, but yeah, I realized that this can solve quite a few problems already. Like if you imbue it with this thing called object view, right? This object view, I tried to do it because the GPT text-based object view is not that great. Okay, so what we do is we run a program to do flood fill for every single like color like that. Okay, and what happens, you get a list of coordinates. I save it as a shape. Okay, so there was a paper, I think, I can't remember the name. I'll link it in the video, but there was a paper using GPT to like do object view as well, and they showed that this paper did way better than using just the raw pixels of the grid. Okay, and I also found the same conclusion, but over here, instead of using coordinates, okay, I just put the shape here. Okay, because it is in my hopes that GPT can associate shapes by just looking at this sequence of tokens and then say, oh, the input tokens is like that, the output tokens is like that, there's a match. So actually this is correct. GPT can actually view shape. So this shape parameter is good. And then in order to do like some form of invariance, okay, I actually hard-coded the invariance by separating the color of the shape as a separate variable. So red color square and a blue color square will have the same shape, which helps GPT do the association. So this is a bit of handcrafted representation to abstract out the priors that I want GPT to have. Then of course I have a top left corner to tell GPT, okay, this shape, where did it appear in the input? Okay, initially I also had bottom right. Okay, then also we have a size of the cell, size of shape, number of cells. Okay, I took them out because the token length was an issue. Okay, but I think I will have to put in number of cells back because the number of cells are used in quite a lot of training problems, which it got it wrong. Okay, I thought, you know, you could perhaps count the number of X here and find out the number of cells. It couldn't do that. Couldn't do that reliably. So maybe I need to put in number of cells back here. But you know, the more things we put in object view, the more tokens we use. So I really wish we had like unlimited token length, because there's a lot of things you could represent as an object view, but I had to cut short because of that. Yeah, but this is like one of the most performant right now. I'm still experimenting on it. I just want to share with you like what I think this shape thing is good. Okay, this is good. Okay, because if you use coordinates alone, you may not. Okay, imagine if you are GPT and I give you coordinates like that, 2, 1, 2, 2. Okay, versus another coordinates like 3, 4, 3, 5. Okay, will you associate these two coordinates to be like the same shape? It's a bit harder, right? Because you still need to do addition, you know, to make sure that, you know, everything is you can mitigate this by saying that, okay, the top left is 2, 1, and then the shifted coordinates is 0, 0, 0, 1. I mean, you can do something like that. Yeah, that would perhaps like do something very similar to what I did for shape. Yeah, so
I pasted in the chat that I did a little test to see how large all the grids were. And if you look at is mass less than equal to 200 or no 100, that would mean that there's if every grid in that riddle, there's less than 100 pairs, pixels. And that was for 745 tests. It turned out that there was less than 100 pixels. There's some really huge 30 by 30s that like look scary, but when you actually do the whole test, those are not that many. Anyway, so that's kind of just some metrics that I gathered. Is the mass greater than 200? Yes, 41 of them. And this is for all the grids from the input to the output. Just wanted to show you that.
Yeah. Thanks. So it turns out that maybe if you just represent it by coordinates, you can omit the entire grid alone. You can omit the entire grid itself. Right, then you might be able to reduce the tokens. Yeah. So anyway, I'm just sorry. Yes. Sorry, I interrupted.
I just go.
Yeah. So this one still needs some experimentation, but based on my experimentation, this shape is superior to the coordinates because I did both. It managed to do the shape one quite well compared to just coordinates. Yeah, of course, this shifted coordinates is something I've been thinking of. Okay, because if you do shifted coordinates like that, you might be able to relate like the two shapes to be similar to each other. So this one I haven't tried out yet, but this one may be superior to shape. Okay, so these are some ideas that I have. But using this shape can solve quite a few problems already. Okay.
And this object view is human generated.
Yes, it's generated
Got
by
it. Understood. Okay.
Yeah, you have to give this to GPT because GPT doesn't reliably give you the objects, even with text
Understood.
prompting.
Okay.
Yeah. So fact checking, right, is also an issue. So what I realized is that you could just give it some examples of, you can actually ask GPT to generate Python code. So Python code initially was generated quite badly because if you just use text-based, it's not good enough. But we can actually give GPT some helper functions that are already crafted, okay, to ground the generation for the Python code. So for example, the get objects code is what we saw earlier to get this. So you can just say, okay, this is the description of the code, takes in the grid, okay, whether or not the diagonals are true or not, whether or not you want to have empty cells form objects. A GPT is actually able to, you know, call this function and change the parameters itself. So it's actually a very, very functional, very flexible program synthesizer. And the idea is you don't give it low-level actions, which is like low-level grid manipulation actions. You give it like broad functions like that, okay, to fill up like an object with the grid, with the object, fill up a certain coordinate, fill up the line between the coordinates. You know, if you give it broad functions like that, okay, so the idea is don't ask GPT to generate low-level code. Ask GPT to generate high-level functions, to call high-level functions. So I realized there's quite a lot of promise with this approach because like before this approach, the code generation was like maybe 10% accuracy. I mean, the code, after I give it the functions, if the functions kind of match with what you want to do, the generated code can work more than half of the time. So this is a huge improvement using these functions to ground the kind of generation of the code. And there's also an additional benefit. The additional benefit is because I give it some input-output examples like that, it's actually able to use the input-output examples to come up with the solution. Okay, because previously, like if you want to do rotation, it doesn't really know how the grid looks like. So if I were to like just say, oh, do a rotation using text, GPT is not able to ground it that well. So you still need to do some form of few-shot grounding. And you know what? You can even use the function as a few-shot grounding. Like then you will know that, oh, these are the parameters of the shape. Or then you will know that, oh, this is how I feel, this is how the coordinate looks like. Yeah, so this is something that I realized giving it input-output not just helps with the code generation, it also helps with the language description as well, because it's able to ground like how different grids link to each other, how the input links to the output by just like applying like this input to output. It can actually do this kind of thing and apply it to another grid. So I think this is the way ahead. Unfortunately, text-based alone is not going to solve up. We kind of still need to ground it in some functions. And it is my hope that we can find generic enough functions such that you can just call them the high-level functions and solve most of problems. Yeah, so this is very promising. And I was talking with Michael Holder on this recently. And I think this way of doing this high-level function calls would be quite I mean, this has a lot of promise. Yeah, I mean, I already tried this. Out of like the 50 training tasks I tried on, I could solve like at least 10 of them, which is like about 20% solve rate so far with just using these functions. I think more than that. I think close to 30. Close to 30 to 40%. Yeah, it depends on the kind of problems. Because all these functions are now currently just mainly dealing with objects. I haven't really did for the rest like pixel view, like overlaying view. I haven't done all these functions yet. But if you do all this, actually you can solve the problems pretty well. And I mean, people, you might say that this is like a bit cheating because I give it the function, right? But I would say that these functions are more like broad kind of ways of approaching the problem. Ultimately, GPT still needs to like match the problem to the kind of functions. So this is some insight I got. GPT is great at matching. Need to give it the right abstraction space to match. So earlier you saw the object view is to give it the right space for objects. And now you see this function here is to give it the right action space to match to. So if you can give the right abstraction space for the input to the output matching, GPT is great at that. Okay, so if we ask it GPT to do end-to-end with just text, yes, GPT is not good. Okay, but GPT is great if we can do it in some space in the middle, whereby you have high-level actions and you have an abstract view to match to the action. GPT is very good at that. So I believe the solution for Up will rely on this part using GPT. Okay, but how to get the right action space, how to get the right input views, this part here might need to be handcrafted. Okay, unfortunately, right now, this might need to be handcrafted. Okay, so before I move on to this, any questions on this part?
Just want to say this is like a very sober view of what GPT is and what it can be good at, and this is why it works. You know, like what you're not expecting too much out of GPT, and it's like the no free lunch principle. You're not just going to get a free lunch for free. You have to work at it, and you're actually doing the right work. So I just want to say I'm very impressed with you just realizing you have to do this.
Yeah,
okay.
I wanted to do without code actually. Yeah, but unfortunately, code is still the way to ground GPT because GPT doesn't interpret like logical facts that well. GPT doesn't basically there's some issue with consistency, and grounding it in code is the best way right now. Not just any code, by the way, it's code that is generic enough, so it becomes a matching problem. So our aim is to make Up become a matching problem of inputs to action space. Okay, so I'm going to talk about the next thing, which I think has helped power a bit of my code. So I don't know how many of you have played this game before, Final Fantasy 12. So the game is not that important. The idea is that you have some conditions of what to do, and then you do a certain action. Okay, so like this is like a list of behaviors that GPT could be, I mean, the code could be prompted such that, you know, if a certain condition, then you do this. If not, then you do the second one, then you get that other one, right? So this if then actually is a conditional loop. This is an if then condition. Okay, but the initial idea of me having this here is actually not just for Up. Okay, I believe this is a very generic robotics solution. Okay, so like a lot of times, you know, for human behavior, we don't get runtime errors, you see. Like if you ask GPT to generate like code to power a robot, sometimes it might fail. But if you ask it to generate code in the form of like, if a certain condition, then do this. Like for example, if let's say talking about humans, like if I'm thirsty, I drink water, right? You know, that kind of thing. If I'm hungry, I eat. So like you just go down the list of priorities from the top to the bottom. And then if it hits a certain condition, it executes the action. And then you can run this whole thing in a while loop. Okay, so this is a very generic like robotic architecture solving. I mean, some people call this finite state machines, but I mean, this is like the behavioral loop that I think works quite well for most cases. And this was actually done for the AI prompting in the Final Fantasy 12 system, which I quite like a lot because you can control all your teammates, right, using some if-else condition, using some if-then condition, so that you don't even need to specify what they need to do. You can specify what context, what do you do? This context, you do that. The other context, you do another thing. So it is very, very flexible. And the best thing is if nothing works right, the AI will just do nothing. It will, basically none of the conditions match, AI will just do like a default action. So this is something that is quite fail-safe. You will not have any runtime errors. Your robot can keep moving. And same thing for Arc, okay? If you do something like that, if then, okay? You can use the same function call and only apply it on certain objects. Okay, for Up, you may not need this while loop. Okay, because in Up, it's just more of an input to output mapping. So let me write this down here. Up is input to output mapping. But we can use the conditional mapping, but as a way to make the code much more generalizable. All right. Let me illustrate this here. Okay, so over here I have a last point here. Because I was always thinking about how like we can plan in hierarchy. If you have this part here as another function call, this will be the hierarchy. So it's either a function call or an action. Yeah, a function call here, it's not really an action function call. It's like maybe you have another if else loop here. So there's another series of if then in this function call, or you can end with an action. So this helps to build some form of hierarchy in terms of planning. You have a high level action, and then you can go down to the specific actions like that. And then these specific actions can call further stuff. So if we were to do this kind of if then through the multiple layers, you naturally get a hierarchy. Okay, so I was thinking about this, like I wanted to call this the instructional code format, all right? Because like it's like giving instructions to your robot, like, oh, if this you encounter this, then do this. If you encounter that, you do another thing. Yeah. But I decided that I will just call it a conditional code instead. Okay, because for Arc challenge, you don't really need the while loop. You just need the if then. You just need the if and then. Okay. Questions on this? Anyone want to ask about this? Okay, this one actually is not just for the Arc challenge. Okay? I'm trying to solve intelligence in general. All right, so this part will be used for like multi-agent kind of challenges. This one I think can be used as well. All right, so conditional code. So let's see what is a conditional code here. Okay, so in Arc challenge, you know, you don't exactly apply the same function to every single thing. So like, for example, you look at this Arc training set here. The relation, you can see that this relation is if the two dots are in the same vertical line, you connect them, right? You see over here, this dot does not have anything in this line here, so it doesn't get connected. Or if two dots are in the horizontal line, you connect them. Okay, if we were to simply apply the same function for every single pixel, okay, there's no way you will get this test output, okay, because this test output is conditional. Okay, can you see that? I hope you can see that. You cannot just blindly connect the horizontal lines and the vertical lines. You must have a certain condition to make sure that there's at least two squares in the same line, horizontally or vertically, then you can connect them. So this is actually done through prompting, okay? I just say that each helper function, so the helper functions are like the few pixel, few object. So each helper function can be conditional. Okay, we can go by attribute, or can do an attribute on all objects. You know, some problems like to say, or number of different colors, you know, in the entire grid. You also can do by position, all right? So I give it some conditions. Over here, I only define one condition. It's called on same line. So like either cohort 1, cohort 2, you see whether is it in the same row, column, or diagonal. So I crafted this function. Okay, but there could be other conditions also, like you could say is same color, you know, that could be another condition. You could define a color like is same attribute, object 1, object 2, attribute. So you can create a function like that. It's best if the function is generic, then you can use for many situations. You can create a function like that to see whether there's the same attribute for various objects. Okay, I have not explored this exhaustively. Disclaimer, I only have tried on about 50 training Arc tasks. Okay, because I've just been playing around to see whether, you know, this works. And this works. Okay, this conditional code works. Okay, along with the functional representation, this conditional code, I believe, is the way to solve Arc as well, because a lot of things are applied based on certain conditions. So you can see that this is how the function looks like. You have a certain objects. First, you get the objects. So you see, very good. You see, GPT can ground in itself in objects just by showing it the object function. I did not ask GPT to do this. It does it itself. That's not bad. Okay, and then from all this, it knows how to manipulate all this. So it checks whether for all these objects, if it's in the same line, you fill the line between cohorts. Can you see this? This all generated by GPT itself. Okay, I'll show you the prompt used to generate this later. But this highlights that this conditional code is very useful. Okay, because if we don't have this conditional code, like we don't use this if function here, okay, GPT might be using a very, very long about route, and it may not even get this in the end, because you still need an if statement somewhere. Okay, over here, I specifically ground GPT using this format. If condition, then helper function. So I grounded this so that this is what's going to be generated by GPT, and this works very well. Okay, so just want to highlight this here. So you might be asking, what's the difference between this and like a domain-specific language? So I was meeting with Michael Hodel. I met him last week. So the thing is, we're going through his domain-specific language. He solved all training tasks of ARC using his handcrafted domain-specific language. Like this, you can check all colors of A, which is a blue color. Then you do some form of like 2 different objects, and then you connect them together, apply. So you can see that it kind of doesn't have an if statement. Okay, the if statement here is like to see whether you can connect. Yeah, so it's like sort of implicit in like the connect here. It's not explicit if statement. And I asked him like, why don't you put the if statement explicitly? And they say that because if you were to do like program synthesis, you kind of need to search through the function space. And then if you have the if statement, right, it's very complex because like not only do you need to search a sequence of functions, you still need to do the if something, then B. So initially it was just like going through a sequence of functions like B and D and so on. But if you do like the if statement here, you still need to search this over here. Okay, which actually increases the complexity of the functional search. Actually, this part I need to ask like Douglas, like if we were to do an if statement in like maybe Prolog, will it be easy to do?
Each one is a horn clause. So what I do is I generate if-then statements in Prolog based off of like the properties of the object, and then I have the output. The then is a edit or a change to the object. And so what I do is I just can either loop through the objects or loop through the if-then statements. And neither one is going to always be the right idea. You use either one. I mean, different riddles will say, okay, I need to loop through all my if-thens. But yeah, there is a if-then situation. And so what I have on the outside is a while loop. While there's still objects that need to be processed, run through this block, and this block is just full of if-thens. And that's how Prolog does it.
Oh, actually, I like that idea. I mean, it's very, very similar to, oh, sorry, let's go back. Oh no. Wait, hang on. My keyboard is jammed. Hold on, let me just fix this problem again.
Well, it's kind of like what you showed with the game, the Final Fantasy. It's a while with lots of decisions asked about.
Yeah, we're back here. So I like what you said. That means maybe we need to do this while loop after all. So maybe my code here is not the best code, because you see over here, I still have a lot of you see, they still need to do a for loop here. If I were to do a while loop, like while all objects have been processed, like look through each object individually and then check if this object is a nut. So you can maybe perhaps convert this to a while loop. Yeah, so maybe that's what Prolog does, and I quite like the while loop actually. Yeah.
Yeah, because you have your training pairs there, not just your output pairs. Don't care about output, but you can actually test if it's going to be a while loop over your every object. Well, I mean, the type of loop you can usually determine during a off of a single training pair by trying it out. Yeah.
Interesting. I think we need to talk more about this, because I think if we can get it to do something like what you see here, this will be very efficient, because you can represent a lot of things with very little information. Like you don't even need to do the for loop. You can just keep doing the conditional code like that. Yeah.
Mm-hmm.
You know, I would laugh if like eventually this is how we solve intelligence, because that means Final Fantasy 12 solved it a few years ago. It's just that we haven't really used it yet. Great game, by the way, if you haven't played this before. Yeah. Yeah. So there's some benefit of using like if statements, because you can reduce the number of code. You see, this is so convoluted. Okay, but I mean, the idea of finding the right if statements will be difficult. And also, like, you can increase the number of combinations exponentially if you just incorporate if statements. Okay, but fortunately, this is for traditional program synthesis. if we were to use GPT to do this if statement, it's actually very, very obvious, because like from a language to if then, it's very natural. Because like if you talk about language, right, most of the time when we say, oh, you take this object that is, if there's 2 squares in a row, connect them. If there's 2 squares in a column, connect them. Can you see how natural this is in language? So to describe this kind of problem in language is very, very obvious. You just need to say if this, if this. So this links very well to conditional code. And I mean, if you also do a while loop, you can also keep doing the same patterns until termination. Okay, then you can do a lot of the other tasks like simulating a light beam, that kind of stuff, can be done using conditional code with a while loop. So I think this is probably the way to go, rather than a sequence of like unary functions, or like in this case, like a sequence of functions in a DSL. Like, okay, so now you all might be interested in like how this is done. So first, like instead of broad to specific, I actually do a lot more now. So I ask it to reflect on, okay, this reflection is like differences between input and output. Okay, so this reflection is also there because this reflection can also be like why code did not work, and also why code generated wrong output. So based on the stage of the GPT generation, this reflection will be different. So it's either difference between input output, why code didn't run, or why it generated wrongly. All right, because I use a form of environmental feedback loop, as you can see later. So I also asked you to describe in terms of pixels, in terms of objects. Okay, so that like this can cover like rotation, symmetry, and also it can cover object rotation and translation. Then I asked it to map like input and output in terms of like, for example, if the output is a subset of the input, this part here will cover the part on how the output is actually a transformation of the input or subset of the input, or how the output is a superset of the input. So this is basically in terms of like which section of the or for example, if the grid is something like a tic-tac-toe board, then each of this is a 3x3 grid. Then the mapping part can say that each of the 3x3 grid will map, okay, to a single square. So this is basically to say that like how is the input grid mapping to the output grid, like in terms of grid size and everything. Yeah. So with this tree here, compared along with like differences, this grounds the overall pattern. Okay, so this will say that. So you can treat this tree as 3 different agents. One agent does it in pixel level, one agent does it in object level, one agent does it maybe in a section level. And then we see which description matches the input the best. And then like GPT is able to just based on like what each expert is saying to consolidate and get the best pattern. Right. Then after that, what we'll do is we'll then transform it, okay, into a Python program. So the overall pattern is in English. This is instructions to get a Python function. So like step 1, do an if loop, do an if then, step 2, do like another if then. So this grounds GPT in a Python program, and eventually you'll get the Python program out. Okay, can you see the intricacies in the prompting here? Like you have to do it in this order. So first you get the kind of different domain views, and then you consolidate them in overall pattern. And then after that, you do a series of prompting again to get the program out. So I quite like this prompting. I tried different iterations, and this one works more or less the best. Okay, it's even more complicated than my initial broad to specific, because I want it to focus a lot more on like what's the difference between the input and output, because I want to, you know, a lot of times if there's no change in the input to output in that specific aspect, it means that that's not the answer. So only when there's a change in that certain aspect, then you focus your efforts to find the answer. And because of the way I prompt, if you see a change in a certain aspect of input to output, you then focus on types of functions needed, which is exactly the case that I want GPT to do. Map the input representations to a sequence of actions, and not just any sequence of actions, a sequence of conditional actions, because the conditional part is very important to minimize the complexity of the program. All right. So
can I ask a question here? So does this new prompt have the same property where basically the description of the problem is still like more than 90% correct, and it's still the problem still seems to lie in the program generation, or is it
It's
different
actually
now?
both.
Is it both? Okay.
If you don't give it the right functions to ground the action space, it
Mm,
may not be able to give you the right overall pattern. I mean, this is actually better than the earlier prompt that I used, but there's also some issues that it cannot solve everything. If you don't give it like how the grid rotates, right, it may not be able to solve rotation problems, because just describing the word rotation in text is not enough.
How good is the description? Like separating the like two problems, which is like describing the change and then the invariance, and then one writing the program to solve it. What is like the success rate for each one? Like there's
I
two
haven't
stages.
really did the statistics for that.
Okay,
Say
okay.
that the
Agak-agak lah. Yeah.
the success rate for the overall pattern maybe 70%,
I
and the
see.
program
Okay.
maybe 30%.
I see. Okay.
Yeah.
Thank you.
So a lot of cases, if I look at the overall pattern text from the GPT, I would say that GPT passed. But unfortunately, the program did not generate what is it.
Understood. Okay.
Yeah, so it's the same issue as earlier on, but this is much better now because now the code is consistent. Okay, earlier on in my initial one that I used the language itself to like do the mapping, right? There's some inconsistency because GPT may not be able to get all the pixels mapped correctly. But if you ground it in code is consistent. So I'm using the best of both worlds. I'm using GPT to do the inner part where you want to match the abstract space to the action space. And I'm using the code to do the consistent action. So I think you need a combination of everything. You cannot just use GPT end to end. Okay, this is what I realized. All right. Okay, so let's see like this one here. How does the generated output look like? So you can see this is a test input is this blue square, and then the output you need to get this pattern out for every side. Okay, this is not that easy, all right? I mean, it looks very easy for humans, but in order for GPT to know that up, down, left, right here needs to be done in a certain way, it needs to firstly know like, okay, for each blue square, I need to do a certain thing. Yeah, so this is a pattern that is not difficult, not easy to do. So this is what GPT outputs. So let's analyze them, okay? This is the first part. No change in grid size, okay? So there's no expansion, no contraction, okay? So this is actually very good because like, as I said, if there's a difference means you can focus your functions on those differences. So no change in grid size, okay? Number of objects increase. Okay, so maybe this problem is a problem of increasing the amount of objects. But how? With multiple new pixels appearing around the original A pixels. Okay, original A pixels do not move. Okay, so this is not a problem of translation. So you can see constant input-output mapping equals to no need to focus there. Okay, see, we are trying to eliminate the problem space. We are trying to filter the problem space. Yes, the problem is there's so many things that can be done, right? And this reflection is trying to filter the problem space iteratively. It's actually working very well, right? Object sizes generally increase, okay, because the A become multi-pixel outputs. So not bad, you got all this correct. I give it an A star for its reflection actually for this. So for the pixel is there does not seem to be any consistent whole grid transformation. Okay, so this one we eliminate reflection, rotation, symmetry filling, because there are some problems that need this. Okay, so this is good because it means that this expert on pixels can be disregarded. Okay, because this is not exactly a pixel problem, but you can see that it happens independently for each pixel. Okay, so this is like a series of experts contributing to one big problem. Yeah, then now we have the object expert. Okay, the object expert will say, yeah, initially the objects are single pixel A. And then now I surround each A object with other pixels forming a larger object. So you can see that this corresponds quite well with the reflection. Okay, and this means that, okay, there's more people trying to vote for like this particular way of doing things. Okay, so like A pixel is surrounded by this, okay? And then now we do the mapping. Okay, this is the section view to see whether or not the grid change or not. This doesn't involve transforming whole sections of the grid. So we already say that we eliminate overlay of sections. Okay, and then around each A pixels, other pixels are placed. Okay, so this one again, you know, kind of says that it does not have anything to do with location or grid. So we already eliminate this particular expert. So we can say that, okay, this problem is a problem of object, right? So it's quite cool because this is exactly like how we solve the problem step by step, eliminate stuff out. Okay, then we can say that, okay, so the mastermind of the code, overall pattern, what's the pattern now? For each A pixel in the grid, place a G to the left, F to the right, H below, and B above. Okay, so the instructions will be start with the original grid. For each A pixel, they get the coordinates, place a G to the left, F to the right, H below, and B above, and return the modified grid. And then we get the program here. So the program is in a list of it's in a string with /n and /t. If we print out, this is the program. All right, look through every coordinate, do each action like that. So you can see that over here, it solves it exactly, okay, as what we needed. And all these are done end-to-end GPT. I didn't do anything. Yeah, I provided this field coordinate function because for the list of strings, GPT sometimes try to assign a character to a string. And as you know, a string is immutable. So I created a helper function called field coord, and I say you must use a field function. Yeah, so this is like some intricacies of how this works, but I believe if you ground it with the right functions, you can solve almost any problem. All right. So anything you want to ask about? Okay, if not, I would like to tell the last part, okay, of what I did. Okay, the last part I did was actually focusing on this iterative prompting mechanism. All right, so this is the Voyager, where using large language models, an agent can learn in a world. So right now, the code itself that GPT generates is like one single step. But what if we can ask the environment and then we ask like, okay, is the code correct or not? If the code is correct, then nothing needs to be done. If the code is wrong, then you ask GPT, hey, your code is wrong. Can you analyze? Can you reflect and analyze and see why your code is wrong? And this actually for simple problems, okay, can help to solve it already. Like it manages to increase the number of problems solved by using this iterative prompting mechanism. And I prompted it like maximum 4 times, so it's similar to the Voyager because like my GPT-4, I only have 25 messages every 3 hours, so I cannot try too much for each problem. So this is something that is quite cool because this actually works, right? And of course, this part here, like all this skill library here, this actually reminds me of, the functions or the action space. Yeah, it's just that for up, I don't think I will want to add any extra action space here because like each problem would be guaranteed to be quite unique. In Minecraft, like in order to craft like a diamond sword, you might need to craft a stone sword first. So you might need to reuse the entire set of actions for stone sword. But for up, the chance of reuse will be quite low, right? We just need to define the most primitive basic functions and then use GPT to match the abstract input to the action space, all right? So this is the overall flow of generation, the ideal one. So first we classify the kind of problem that we need, okay? And then right now I'm doing this classification and the prompt together, okay? But this ideally should be separate. So you can first do some examples of the different kinds of problem, then filter to the respective agent that is in charge of it. The agent will have a very detailed list of functions that you can do, like pixel manipulation, object manipulation, section manipulation. Okay, and then we give it the right abstraction space. So for example, objects, then we give it the object view. Section, then we give it section 1 is here, section 2 is here. Then try to combine the sections. Pixels, then we can just give it the entire grid of pixels. All right. So this is something that I want to implement, but I haven't implemented yet. If you can ground it with some examples of like how this specific problem type, some examples of what have been solved by that, perhaps GPT may be able to choose the functions appropriate for it. Okay, so this memory bank helps to ground the generation of the output space. So first, using the action spaces, okay, we can get the description of programming words. Then we can use like maybe the action spaces, which is like the functions, okay, the helper functions to ground the code. Okay, this action space can also ground the prompt here. So a lot of grounding involved, and this helps to make GPT's output more reliable. Okay, then we can check again, okay, is there a compile error? If there's a compile error, yes, you feed in the compile message and put in reflection, and then ask GPT, hey, your code is wrong. Correct it. Okay, it works 99% of the time. You can correct the code. GPT is quite good at code correction. Okay, if the output sample is wrong, then you ask, hey, your generated samples are wrong. Reflect on why it's doing that. So like about 50% of the time, you can correct itself and say that, oh, I failed to account for the fact that there's an extra pixel on the left. Let me correct it. And then the code can be correct. So if this training input matches the training output, then we are done for the day. Again, hope that our code works for tests. And actually, most of the time, if you are done with this step, the test is done already. Okay, so right now, I think I got the flow out. I just need to craft my functions to make it more generic such that it solves most of the arc challenge. Okay. All right, so let's take a look at the demo. Okay. I think I might have to exceed about 15 minutes today, but I hope you all don't mind because I think this demo was quite interesting. Okay, so I'm just going to show you how this code is done. All right, I already have this code. I've given you all the link, but let me just run this code from the start again. So this is like some example of like how MATLAB like displays the output for the grids. Okay, this is a utility functions for the objects, which I use to like, for example, get the size of the object, get the top left coordinates, and output the shapes based on coordinates, you know? Yeah. So this is like the objects to arrays function. Like, for example, given an input grid like that, we can get an object of value A and value B. So over here, the 1 is an A and the 2 is a B. Okay, of course, as what I mentioned earlier, you know, your object view, maybe it's better to leave it as numbers, you know, I don't know, or maybe it's better to put commas between the X. This one, once the context length for GPT-4 has increased, I will go and try to perfect this representation. But as of now, this is good enough. All right. We have other helper functions like this. So all these helper functions, okay, are created by me. Okay, these are actually meant to help GPT like, okay, convert like a certain shape to a coordinates. Okay, in case they need to do by coordinates. Okay, fill up the object, fill up an empty grid. Okay, crop the grid. Okay, you can see the helper functions. Where is it? Crop the grid, fill up the coordinate, fill up a section, get some coordinates of a certain value, fill up a line, get some counts of the value. So this one is like to find out what's the maximum and what's the minimum color of an object and so on. Rotate clockwise, flip horizontally, flip vertically. So kind of obvious these functions. I mean, but for GPT, you kind of still need to give it some examples of how to do this because just language grounding is not sufficient. Right, so these are the unit tests that I did to just show that like it's working. Right, then this is the conditional function. So far, there's only one right now on same line. Yeah, I'm working on more. Okay, so this is the way to do it. First, we download from the arc. This is from Lab 42. So you can uncomment this and download the set. So after you download the set of things, you can see that there's evaluation and training. So like each of them appears like in a JSON file like this. Like these are the different input-output pairs. You can see that this is like how it looks like per line of input. So basically, we download the JSON file. Okay, so I'm just going to show you this one. Okay. So like, for example, this is a problem where you need to take this object here and you need to flip the colors. All right, so let's take a look at like how. Okay, so this is give the object view to GPT. Okay, and then we ask it to, so this is the prompt. Okay, the prompt is like this. This is a list of strings. Okay, and then you have to infer the simplest possible relation for input-output pairs. These are the helper functions that you can use in the format, function name, function description, and the sample input-output. So these are the helper functions you saw earlier. I only implemented a few. All right, and this one, my ambition is eventually there will be specialized agents that do this, like object view, pixel view, so that you can put more in the prompt. Because right now I'm facing a limit of my context length. All right. So these are like the conditional part. And this is the overall way of doing it. So this actually is quite good because GPT understands what to do. Right. Okay. And then what I'll do is I have this whole thing generated. I mean, just copy and paste this one. So you can see that this is the JSON file that has been converted to letters in the list of strings view, and also each of the objects like that. So let's take a look at ChatGPT. Give a GPT-4 like that. We just copy and paste. You can see this is the prompt that is given to GPT now. And GPT will then generate in a JSON file, okay, what it is. So you can see the grid size decreases from input to output, forming a large rectangular grid to a smaller square one. All right, number of objects maintains the same, but size changes. Specifically, the larger objects decrease in size, smaller ones stays the same. Okay, so you can see the pixel is getting cropped. All right, object view is larger gets replaced by the smaller one. Smaller remains the same, but changes to the color of the larger. So description mapping will be the input gets mapped to the output by cropping. So you see, it uses the functions that I've given it as a way to define the action space. All right, so the overall pattern for all input-output pairs perform this: crop the grid to the region occupied by the larger object. Okay, replace the larger object with the smaller one. Okay, change the color of the smaller to the larger one. So this is the instructions. Okay, and then this is the program. So let's just copy and paste and see whether it works. So eventually this should be done by the API. So if we were to replace this output string here, okay, so this one ideally should be done by the API. Okay, then we have this overall pattern, and this is the program that is generated. Then we see whether it works. Okay, so this checks whether there's any compile error. Check whether it works. Okay, now this gives an incorrect solution. Okay, and we see what's the issue. Okay, you see the issue here, it did not crop properly. Okay, so this is a good example, because just now I tried this, it worked first time. So it's a good example. You can just copy and paste this whole thing here back into GPT for the iterative prompting process. So you can see that what we will do is, this is your code that you have generated earlier. There's no error message. Okay, this is the previous pattern that you identified. Your code did not generate the correct output. So let's see whether or not it can like correct itself. So let's take a look. Current approach identifies larger and smaller objects, crops the larger objects, replaces it with the smaller one. However, the scope does not properly handle the replacement of the small object's color. Okay. So I ask it to generate again one by one. Okay, to be honest, I don't know whether this code will work, but let's just copy and paste and see whether it works. So ideally, this one should be done by the API, so it will be like a continuous loop, a for loop. Oh, sorry. Oh, it's still incorrect. Okay, let's see why. Okay, so now it just forgot to fill the middle part. Okay, it's actually very close to the solution already. Let's just copy and paste this thing here into ChatGPT again and ask it to generate. So you can see that using this iterative prompting method, the solution space is getting closer and closer to the intended output space. All right, so you see it's much better now. All right, and I was thinking of an improvement to this also. Like we could just give this output here as the starting. If this was close enough, you can just put this as the input. And then ask it to do input output. So like you save what it has done so far, and then ask it to do a next transformation to the output. So iteratively, you know, it could comprise of a series of small steps of programs to the output. So that's not done right now, but I was thinking something like that also, because you see, it's getting closer to the output. Okay, you need to continue generating for this. Okay, so you see the final grid is missing the interior part of the larger objects. Okay, let's copy and paste this whole thing. Sorry, Douglas, you were saying something?
Oh, I was just saying it's almost like a repair. So if it did get it half right, but added 2 pixels you didn't want, you're thinking that it might actually be able to simply figure out which pixels to take away by treating it like a new problem or like a simpler task.
Yeah, I was thinking like that also. So now you can see over here, string index out of range. Okay, so no issues. Let's just, so actually this is a very good illustration of how this whole repair process works. Okay, because if there's a compile error, what will happen is I will copy the compile error here and put it as an error message. And then now let's see how GPT solves it. So again, you can see I I did not need to do any human input. I just let GPT run by itself, and it can do the feedback loop. So if we didn't do this feedback loop, GPT will just get it wrong. But if we give it this output and give it like the compile error, hopefully, it's able to solve it. Okay, so I believe it's able to solve it because this program, it could get the output initially when I tested earlier. Okay, so let's see whether it does solve it. I'm not sure whether this problem is a difficult one for like DSL, but in terms of getting the objects to swap position, I didn't like create a function for that, so this can be difficult for GPT. So let's take a look. But ideally, I don't want to create so many functions because, like, when you do the hidden test set, you are not going to see the problem earlier on, right? Assertion error. Okay, no issues. All right, let's just try one last time. Okay, one last time. If this one cannot, means cannot already. Okay, so it was very close to the solution just now. So you can see that there's some issues with like the code sometimes. So that's why I wanted to do functions so that it doesn't need to manipulate the code directly. Like over here, like it tried to assign, like it tried to maybe assign something to the grid, right? Yeah, I tried to do the grid by itself. So this is not what I want it to do. I want it to use the helper function. So sometimes it's like that. Yeah. So this is one of the issues with GPT also, the stochasticity. That's why the grounding is important if you want to use a GPT solution.
You might just give it a whole library of functions that are already known to work, and then it just grabs the ones and puts them in correctly. You're saying?
Yeah, maybe. Correct. It is able to do pattern matching quite well. If you have a function that can solve, like a sequence of functions that can solve it, like sequentially, it can do it. But in this case, because I don't have a sequential function to solve this, okay, so there's an assertion error here, or it managed to do something that is like wrong. Okay, no worries. Okay, let's just try to do it one last time. Okay, because I think due to the lack of time, we have to sort of go soon. Yeah, I'm just going to show you like how I normally do it. So what I do is I'll copy this thing again from the beginning. So you can see this process is not perfect. Okay, but this, I believe this is more or less the right approach already. You just need to fine tune it a bit. So let's take a look. I just gave the problem again and then ask it to generate again.
Because it could be different every single day, right? Just there's a little bit of random variance in what it is going to do each day. Like, is that correct? So the first time you did it, it went in some direction. Now you're doing it again, and it might actually be fine this time around. Is that what you're saying?
Yeah, so actually this is a pro and a con. I mean, the pro is that you can just keep running the same prompts, and then you have multiple solution spaces. So over here now, string does not support item assignment. So yeah. Yeah, but it's good, it's good. I mean, at least I can illustrate to you all like how this error correcting process is. Okay, but the thing is, it may not correct the errors. So all these are limitations that I'm facing right now. But I'm still optimistic that this kind of approach can solve it. Here, what code did you do? You try to assign a new value to a string. You see, this is why I wanted you to use the, like, I wanted you to use the fill functions. This one didn't use the fill function. I think this just directly assigned like that. So if you replace this with the fill function, maybe it would work. You can see that the description is more or less correct. Exchange the color between outer and inner. So if you mark it based on the description, it's correct already. The only issue is that, as you can see, like Leonard, you asked just now, right? The code.
Yeah. It seems to be, especially maybe not first run, but it seems like after multiple runs, the description is almost 100% close to correct.
Correct.
Yeah.
So if we are able to like do the code better, Oh, still incorrect. Okay, I'm not gonna waste time to do this, but you can see that, like, actually this is so close. You want to try one more time? Yeah, so you can see that the description is correct, but when it comes to translating it into code, that's where most of the errors come from. Like if I were to just grade it on the description alone, GPT could very well solve more than half of it. Yeah, it's just unfortunate that it's not that great at getting the code out. Yeah, which is why I came up with the idea of helper functions, because these functions are supposed to ground the code so that it can generate the right code most of the time. Yeah. And then the conditional code format is also there so that you try to ground the structure of the code so that it doesn't go haywire. All right, let's try it out. Let's try it out. If this doesn't work, I'm just going to stop here, okay? Because I still have a bit more I want to cover. Yeah. And it doesn't really matter if I solve it or not, because like what I'm telling you all today is more or less like some of the reflections I have. So it's in the hopes that people who are also working on this, we can all come together and try to solve it. Okay, so you can see there's some issues here. Okay, no biggie. Okay, so sometimes it solves, sometimes it doesn't. Just now when I tested it, it solved. So sometimes it doesn't. So no issues. I'm just going to stop my share here. We go back to the PowerPoint slide. Okay, so unfortunately that was a failed demo. All right, but sometimes it solves, sometimes it doesn't. And the more you ground GPT, the better your generation is. So I think just now, what I was telling y'all, like if let's say it generated the wrong output here, okay, I'm thinking of doing a new step, a new process over here, okay, which is like if generated output is closer to output, okay, then the input to output. Okay, so what does it mean by closer? It means like maybe fewer changes. Okay, then just treat generated output as input and solve the new problem. Okay, so I hope you all understand what I'm talking about here. I'm saying that we can do a progressive step towards the solution of the problem by just saying that, oh, what you have done so far works pretty well. You're just left a little bit. How do you solve the little bit? So maybe this way will help the GPT to like solve the problem better, because I can see just now all it needs to do is to fill up that little square at the center. So this, I tried to code it out. This might actually solve more of the tasks. But yeah, so I think that was a great example of how the iterative process works. So anything you want to ask based on what you all just saw, like how this process works?
I have a suggestion. Hope it's not too naive, but like maybe one solution to, because it seems like the problem is on the code generation. Maybe the initial prompts, that means the blue boxes here, right? The initial descriptions generated by the kind of experts maybe should be, how do I explain, like grounded in more, like you should maybe write a description. Example would be write a description that can be easily converted into code.
I think you're talking about this part here.
Yeah, sorry. That part. Like initial part where it's generating the description of like the objects, description of like how to solve it. Instead of making it more language natural, maybe it should be geared more towards
more domain
writing. Yeah, being able to write good code to execute on it. Yeah, that's maybe one idea. Yeah.
I basically like your idea, because this is the example of few shot prompting. It's currently lacking right now because I don't have a memory bank of past examples yet.
I see.
Yeah,
okay.
I'm still trying to get the functions out, but this is the idea of my architecture. I think memory would be very important, and this memory can also ground. So basically, based on what has been done successfully in the past for previous arc tasks, you can, although the arc task is not repeated, the functions that you use can be repeated. So GPT might be able to infer that, oh, for objects, I should use this few object function. Yeah, so what you say is exactly right. It's not naive at all. It's correct.
I see, okay.
So I think this will be like the way ahead. Okay, that's a great segue into my last part. Okay, because I just want to show you like some ideas that I have to improve it further. So one way is to give it better input representation. And I was thinking like maybe we can, image domain is very high dimensional. Why not we treat it like we slice it up into like asking some questions to the image, like are there straight lines, are there squares, are there change of objects, and then like get an answer. So I was thinking initially my very naive view is to use this blip, which is like a visual question answer. You ask an image a question and you get an answer. Okay, but I went to do some experiments, and if I feed in the image there, it will just tell me a pixel of a grid of pixels. So it doesn't exactly tell you what it is. So I realized that maybe a better way to give the input representation is to say object view, pixel view, section view. You give it this view itself. Yeah. In fact, the questions that I was thinking of to ask the image the questions, you can do chain of thought prompting. You can do chain of thought prompting to ask GPT are there differences in the objects? Are there differences in the grid? So we don't need, okay, I come to the conclusion that we don't need this visual question answer because this visual QA is trained on natural images, it's not trained on ARC. We just need better prompting, okay, and we need better input views. And as you saw in the earlier architecture here, this problem type specific abstraction space, this is the view I'm talking about. Like an object, is it diagonally connected or horizontally connected? It's fixed. Once you give it a certain view, it kind of changes the way we approach these problems. So maybe the solution is to give it multiple views, okay, and just let it choose the best view. All right, so there needs to be multiple parallel agents running, and then you see what agent gives you the best outcome. All right, so there's another idea of memory. So like, for example, in the earlier broad intent and the detailed steps, so now detailed steps is replaced by functions, functional approach. Okay, you can also do the same thing. You can reference some similar broad intents. So like once you say, okay, reduce the input grid to a smaller size, all right, you can then show like past examples of what has been generated before, and then it can help to refine the word description to something that has been seen before, right? So this is like known as memory referencing, or there's also another way of doing memory recitation. Yeah, I won't cover the details, but recitation is basically mapping the memory into the current instance by using a prompt, by saying that, okay, give me the memory updated to this particular context. Yeah, you can prompt it like that, and then you can get the memory updated to this context, so that you can like use memories from different contexts that are similar, and then you map it to this context. Right? I mean, I covered this a bit in some memory video. I can also link it there. Yeah, but I'll just skip this for now because it's quite late already. So you can do this for the detailed steps. We can also, like, in this case, the detailed steps is a program, so we can just use several programs and map it to the current one. Yeah, so haven't really tried it out, but there's a lot of promise for using memory to be able to generalize to future ARC tasks. So this part here definitely will be something I'm interested to work in the next few months. All right. First, I'll get the functions working. Then we incorporate memory. Then I think this will be a very powerful architecture. Then this is what I was talking about earlier. Because the context length is difficult to incorporate everything. We can have one doing object, one doing segment, one doing pixels. Each of them can come up with some program, and then we just need to evaluate whose program is better. It can be a mini competition of some sorts. All right. I like this idea a lot because this means that you can actually specialize in a certain task. Yeah. And you can have a collection of specialized agents. Yeah. And if you do the iterative environment thing, your specialized agent might, okay, I interpret as object. Then after that, in each object, maybe you need to flip the object or something. Then you can take the specialized agent output for the object and then pass it through to the pixel agent input. Yeah, so you might be able to do like this kind of chaining between specialized agents, which will make the problem much easier. Okay, so a lot of future possibilities here. And this is the idea. Okay, if I have infinite resource, this is what I'll do. I'll have different agents, different ways of prompting. I get a large solution space. Okay, and basically this uses GPT to evaluate, yes, or you can use the GPT's generated program and check if it passes the training set. So you can get a lot of solutions and then you do the grounding. So it's very similar to AlphaCode, where you do a large scale sampling of the GPT, because GPT is stochastic, and if you prompt it differently, you get different outputs. Then you can just basically ground it on whether or not it solves the training set. then from there you just choose the best candidate to output for the ARC challenge. Okay, and that's all for today. I hope it was interesting for everyone. Maybe a short 5-10 minutes if you all have anything you want to like discuss or any suggestions. Okay, I don't have the full solution yet, but I'm just highlighting an approach that I think is very promising. Yeah, so yeah, thanks for listening. Maybe we just have like some time if you all want to ask anything.
Thanks for sharing this really interesting approach, John. Have you tried using 3.5? Like, is it significantly worse than 4?
Yes, 3.5 cannot be used.
Cannot make it.
It doesn't
okay.
even generate the text description well.
I see. Understand. Okay.
I think the main reason is because for 3.5, it doesn't do this part well. It doesn't do the JSON to. So like, for example, if
I see the recognizing of the objects, is it?
Yeah, correct. So if I were to pass this to 3.5, it has no clue, because right now we don't have a good object representation. It has no clue. Even if I pass it like this string of objects here,
yeah,
it's not that great yet. It's still not as good as GPT-4. Like it will stumble a bit. It will say like, oh, give a very generic thing that doesn't really make sense. Yeah, the problem with GPT or ChatGPT is that it still relies a lot on words, or you still need to give it like words. It can summarize pretty well, but when you give it stuff like this kind of JSON file, ChatGPT cannot be used. I mean, it can be used, but it's not very good. Yeah, unless we find a way to describe the input as a series of words, then maybe we can use ChatGPT. But right now, cannot.
One potential suggestion, though I know you already mentioned that context length is an issue. One potential suggestion I had is maybe because I saw when you generated the new output, you copy paste the chunk of output generated by a Jupyter Lab notebook, right? And then copy it back into GPT-4. Potentially, if you have more context length and the context window is larger, maybe you can also copy the previous input, because I think the sequence of inputs will allow it to maybe correct its answer better. And
okay, you're talking about the previous output, is it?
Yeah, like you copy it instead of like giving it just one chunk, right? Give it the previous chunk so you can kind of learn from the past mistakes.
Oh yes, actually, it's already done. Like
it's already done. I see.
Like for example, when we get the where was it? Let me just go back here. When I asked it to generate, I actually give it like a code output here also. So it has 3 views. It has the input, output, and code output.
Oh man, I meant the previous version of it, because it runs in a loop, right? So the previous 3 input stays the same. So the previous output.
Understand. So you have
like a sequence of
different
then you can see kind of like what it did wrong, how maybe from there it can maybe doing you code it, because you mentioned just now that you wanted to feed it from like the next sequence as the new input, right? You want to feed the generator output as a new input if it's close enough to the correct output. If you do that, maybe GPT-4 already can detect that it's closer. Yeah, so that's like an easy way.
I like your idea. I just
but there's no context length.
Not feasible right now. Maybe we wait a
length.
few more months. Actually, I did want to do something like yours. Like what you said, like put in the past history. It's just that the history is just very, very long.
I see. Okay.
Yeah, but good point there. Yeah. So I also see this issue whereby if it can, like let's say it sees that forgets to fill in the square. So what it does is that the next code will fill in the square.
Yeah, but then it forgets the previous
forget to fill
instruction.
in forget to center object.
Yeah.
Then if you do this right, it actually can just keep going in this loop like that and like that. It will just
exactly.
Yeah. So this is a small issue with this iterative part is because of the way that we condition it. Like it just focuses on the problem, but it may not actually
it's a bit similar to your memory bank, I guess, because if you can kind of
after talking to you, I realized how to do it without doing the history already. Because recently I've been teaching a course on using GPT to create games in Python. So I realized that you could just give it a prompt saying that use the generated code and incorporate your new changes ensure
The functionality is
original code's function still works. Something like that. You could do
makes
something
sense.
like that. And then it would prompt GPT to focus on maintaining the function. No, maybe that will work. That's a good point.
Interesting.
I can go and try it out like after this. I think this might help it.
Right. And then just now, actually, when I mentioned about the Python, the description of the generation of description, actually, I think I meant a slightly different point, because right now I see that when you generate a JSON, the text that's formed is very natural language readable. Is it possible to go to the Jupyter Lab notebook?
Oh, yeah, sure.
So the description as formed is very natural language readable, and that's good in its own way. But maybe the problem, because I see that majority of problem actually is in generating the Python code. The natural language description does a pretty good job already. So
Maybe
instead
we just
of
look at this,
like maybe instead of doing making it like natural language readable, the prompt for this can be give instructions or descriptions that are easily convertible into Python code. So you sacrifice about the readability for better output in the second phase of the.
but there's this part here, you see.
That was going to be my exact suggestion. Tell it to summarize in English something that could be converted to Python much easier. I mean, that's kind of what you said. Just so where there'd be an intermediate step right before generating the Python.
Okay, I see what you mean. You're saying there's already a prompt here saying generate program instructions from the previous description.
Yeah, correct.
Understood.
So,
Okay.
Oh yeah, I see that now.
The issue is not about getting the instructions for the Python program in a Python way. The issue is actually this part here. So this part here, sometimes it tries to like assign values by itself, or like it doesn't really. So what I feel is the problem is it has probably a lack of examples for this kind of program. Because what I do is, if you look at my prompt, I give it all the helper functions, I give it the conditions, but I never once gave it an example of a program.
I see.
Yeah. So maybe if I sacrifice a bit of tokens, I give it, this is an example of a program, then I will use like some like few cohort in my program example, so that GPT knows that, you don't just assign the value yourself, you use this thing. Because you see right now, how I do the few cohort is here. Like, oh, I removed the line. Oh, no wonder it's not working. So like over here, I used to have a line saying that if you want to change the grid, you must use a fill function.
I see. Okay.
I took it out. Yeah. So maybe I need to do either an example up here, or I need to put it down here. But I think the example might work better, because GPT generalizes quite well using few short examples.
Interesting.
Yeah, so I quite like the suggestions made by you all. I think this is the way to go. You can see it's so flexible. Whatever idea you have, you just type it out in words, GPT will react accordingly. I think that's amazing. Yeah, that's amazing. This really shows that it's very, very possible that this can solve up. I mean, you look at the description already, it's really so good. All right, it's just
I think the description already is the answer. Yeah, the problem is converting it to code. Yeah.
Correct. So this is the challenge. If we can find a good way to ground the code, which I tried to do with the conditional code format, it actually works. Okay, right now I just need to say that, okay, don't use assignment. Okay, use the fill function. Maybe this will get the code out already. Yeah, that's something that so the prompt engineering part can be refined a bit. Okay. The other thing I was thinking of is, can we actually do the functions over here without me typing it, because it's very tiring to do all these functions. Yeah, I was thinking whether there's a way to automatically learn this, and maybe there's a way. Yeah,
there probably is a way, but it would have to be like a pre-processing step outside of this, I think.
Yeah. The problem is Arc has a lot of human priors. So like humans is like, oh, things are in a straight line. Why don't we do it a curved line? But human priors, we fill up objects like in terms of straight lines. We continue the pattern in straight lines. That is why like these functions need to be done by humans. Yeah, because these are our priors. These are human priors encoded in the functions here. Yeah, you also realize that initially my prompt version 1, all these actions here are all in terms of text, but now they are all in terms of functions. So the more functions we have here, the more kind of functionalities you can do, because these functions here are the kind of things that ground the generation of the output. In an ideal case, I will have all the primitive actions needed, and GPT will just need to, like from a supermarket, choose the items that you need, choose the functions that you need. That is the end goal. Okay, but unfortunately, I don't think that's possible. So GPT will still need to generate some stuff on its own. Yeah, but I have to ground it as much as possible so that you minimize the chance of having a code error.
Potentially, like instead of you mentioned just now the hierarchical, so maybe like part of it will be when it's trying to solve it, instead of trying to solve it in one shot and generate the correct Python program, you'll first try to generate one of these functions and then have its own test cases. And then once it passes its own set, then it adds it to the list of available functions. Does it make sense? Because I don't think it will do as good a job as writing this sub function, these raw functions, and then also try to solve the main problem.
Yeah, actually, to generate these sub functions,
yeah,
I actually use GPT to generate.
So it's already kind of done by GPT.
Yeah, I'm a very lazy programmer, you see. So like all these things over
I think
here.
this is the future of programming.
Yeah,
so
all these things over here, I just like say, what do I want to do? Then I just give it the input and output, and then this is generated by GPT for most of them. Yeah. So I think there's potential in GPT generating these functions by itself. You just need to ground it to generate it. But the thing is, you see, these are all primitive functions that are thought of by us, because like these are how we would solve using our human priors. Yeah, I think it's possible to give the human prior to the computer and say, convert this to code. I think that's okay. But to come up with this list of human priors, that is something that I don't think you can do with the up set itself, because the up set is like, it doesn't tell you what are the priors. You just need to know the priors in order to get the solution. Yeah, I don't know about this. This one is something that I've been thinking about. Like if we don't even do the human priors, I think up is impossible. Yeah,
I really like the approach you took to the loop kind of solution and refining, because the reason I like it is it seems very natural as to how we think about a problem. I've downloaded the arc set and tried it myself, and the way you kind of solve it is you come up with a hypothesis, right? And then you, like, let's say just now the example where it draws like there's like a blue square and then it draws like 4 squares around it.
Yeah.
You think of a hypothesis, then you apply it and see whether it matches it exactly 100% in the test set. And then if it does, and also if your hypothesis is simple enough, then you think it's a good candidate for the solution. I think that's kind of replicated here in this loop.
Yeah, I like it too. I mean, this loop, I actually learned it from Voyager.
I see.
Because the last few weeks I've been presenting on Voyager and Ghost in the Minecraft. So this recursive loop is from Voyager. Ghost in the Minecraft taught me that you can just use a set of actions, and you can you can just have a sequential list of action functions, and you can solve it already. So that's what I tried to do with this format. Yeah, a sequential list of action functions, but I do conditional, because unlike Minecraft, to solve up, you cannot apply the same function. Like Minecraft, you just need to move, shoot the zombie, that kind of thing. There's only one agent, you don't have any conditions. You just shoot or you just move. But up, you apply different functions to different objects. So there's a need for conditional coding. So actually, the last few weeks of looking at all these papers have influenced my way of doing up. And I tried it out, yeah, and it works. So I'm actually quite excited. Yeah, so if we can get the code to be better grounded, so I'll take your suggestion, give some examples, and yeah, I think maybe we need to give some examples of working code using this part here in order to get the code to be better. Yeah, so yeah, I think I'll do that. Yeah, but one of the first things I'll do is this part here, which is like doing some form of iterative loop to the solution, like basically like ask it to retain functionality or treat the generated output as the new input and solve this sub problem. So we can actually solve like a sub problem using this feedback loop as well. Okay, yeah, thanks, Leonard, for the discussion. That was very insightful. The rest, any other things before we end? Okay, if not, thanks for your time. And yeah, I hope to share more about this like in the next few months after I do a bit more experiments. Yeah, so this one, I hope, okay, this is my own personal target, all right? Hope to solve at least 50% of the evaluation tasks by end of the year. All right, so I will not use the evaluation task at all for the generation of the functions. I'll just use only the training tasks. And I hope that just by doing this loop itself in an automated manner, we can solve at least 50% of the evaluation for the ARC challenge. Now, unfortunately, I won't be able to solve the hidden test set because right now you need a Docker which is not connected to internet, which means that unless we have a GPT-4 that is local, this means that we cannot use this for the Docker submission. Yeah. So yeah, ending on this note, if you have any good ideas, feel free to share with me. And yeah, it's either like through like the Discord group, or like if you have like, I don't know, direct connections with me, you can just message me or something. Yeah, I'm very interested to like work more on this and solve this. All right, thank you.
Thank you.